So this is a tutorial on how to make a virus-proof face mask. So a significant challenge with the novel coronavirus pandemic is that despite having social distancing and lockdowns across the world for over 2 months now, and also having face masks become widespread, new cases seem to continue fairly steadily. So I think experts now agree that we don't fully understand the modes of transmission of this new virus, and certainly airborne aerosol transmission seems possible. As well as we need to recognize that the current face masks are probably not fully effective preventing the further spread of this disease. So about social distancing, we know from modeling research studies that sneezing and coughing can send droplets containing the virus over several feet before they fall to the ground. So that gives us our prescription for social distance. But these droplets are mostly water, mucus, saliva, and as they evaporate, the much smaller virus particles are released to become airborne aerosols and can easily spread. Um, Now we know even moist particles, even those as big as 10 microns, can actually travel very far. Um, Now a micron's a millionth of a meter, so actually you have about 25,000 microns in each inch. And the droplets again are about 10 microns. The actual virus is 1/6 of a micron, so it's really, really small. But even these big water droplets, which may contain pathogens, can actually get around very far. And we have evidence of that from clouds. And also, as we see in the San Francisco Bay Area, fog, which can spread over a very wide distance. So all of this highlights the need for effective masks. The only protection we have from the virus entering our nose and mouth, our airways to our lungs, is with an effective mask. And even the gold standard of face mask, the N95, is not as effective as it should be, as it needs to be. And this is confirmed actually by the FDA's own website. The specifications for the N95 are that it blocks 95% of particles above the size of zero point 0.3 microns. And the FDA also admits there that it does not, even a properly fitted respirator, an N95 does not eliminate the risk of illness. Now, we have other studies that also show that once these virus particles are released from the droplets and they end up on the outside of a surgical mask, they can be, they can live on these surfaces or survive for up to several days. So the risk from these viruses is not eliminated by just social distancing or even with a mask that just covers your mouth or and nose. The challenge with the novel coronavirus, as with a lot of these very small pathogens, is that it's very, very small. It's only a sixth of a micron, so that is less than 1,000th the thickness of a human hair. And I guess the key feature of the novel coronavirus is it has these spikes, but also on top of a hard shell, or actually an oily shell. It's called a lipid protein, which may allows it to actually float on water, kind of like this this pond skater bug that I showed for illustration. So it's easily released as these water droplets dry up. Now, just to give an idea of the effectiveness of these masks, even cloth masks. When we talk about cloth masks, even fine cloth can have 30 to 50 micron gaps, which can again allow the virus to get through easily. So again, the current masks only provide limited protection against this virus. So what do we do? So here I think we can learn from the widely known recommendation for protecting against this virus, which is hand washing with soap. And I want to point to this cartoon from the New York Times, which actually explains very well why soap is so effective, or soapy water is so effective, is because the soap molecule has a hydrophobic tail, or I would say an oil-loving tail, which can breach the oily, as I said, the oily shell, or oily protein shell of the virus, to basically kind of dismantle it. And the molecule also has a hydrophilic or water-loving head, which basically draws all these parts, basically dissolving the virus into the surrounding water. So this is a very effective virucide, if you will. It deactivates, dissolves the virus, and in a very simple technology that I propose that we figure out how to use in a face mask. And how do we do this? And I think for that we take some indication from the other modern marvel, the disposable diaper. Basically, the diaper is something that all of us have become familiar with at some point in our lives. Um, and it's the most useful quality, the property of a diaper is that it can absorb a lot of water on the inside while staying dry on the outside. It's impermeable to water going outside, but also it allows breathing, allows air to come in. But again, the key feature of the diaper is provided by the super absorbent layer, which is between the inner and outer surfaces of the diaper, which can absorb up to 100 times its weight in water. It's a very thin layer of a very benign material. It's obviously proven to be safe, for use even with children. And in fact, what many of you may not know is that these super absorbent materials, now very inexpensive, are actually added to a lot of common foods, including ice cream. But even without knowing that, needing to know that, we know that this material is commonly available, inexpensive, and we are going to try to figure out how to incorporate it into a common mask to make it more effective against this virus. Now, I want to just begin by just with a inexpensive common mask, a surgical mask. And just the key function, again, just remind ourselves of the key function of a face mask is to allow breathability, allow breathing, let air in while keeping the virus out. So we see a common mask here. There's a tab on top that would wrap around your nose. And a lot of you may have already noticed that these things are generally impermeable to water. So they let air in, but they keep water out. The water on the outside just beads up and falls away. So what we can do is to open up one of these diapers to reveal the absorbent layer. Here I show, actually I think this was I think called a training pant, diaper for older children. But you reveal this absorbent layer, which is kind of granular, but again, very benign, harmless material. Um, and apply a layer of this, transfer a layer of this onto the inside of a common mask. trying to manage it as uniformly as possible. Once you do that, the next step would be to create this protective moat. And here, after doing a little bit of math, I figured that if we can do this by a mixture of creating a soap solution, here actually a very small amount of it, 2 to 3 teaspoons of water mixed with about a half teaspoon of liquid hand soap. So, this could be any hand soap that you prefer, with fragrance, without fragrance. I prefer without fragrance, because you're going to be putting this into this mask which you're going to wear. And again, these few teaspoons of water are basically easily absorbed, barely moistening this material because it can actually hold a lot more water. And then basically what you have is a uniform hydrogel that forms as this little bit of water is absorbed by this absorbent layer. Then the next step is to seal up this absorbent layer. And what I think I suggest using is another mask. You put the outside of the mask onto the inside of the other mask, and you can just hold it together, fasten them together by just stitch them together, handheld stitching stitching tool, or use a stapler. I think works just as well. It doesn't look super professional, but it works. Um, so the next step is to create a seal on the edges, inside edges of the mask. You can use a soft foam with adhesive on one side, create strips on the edge, which seals off any air gaps, seals off any leaks. And I can confirm that this mask that we have, I was able to wear it for several hours and with no issues with breathability, and made for a snug and comfortable fit. So you have something that feels like a very simple, inexpensive mask, but also included a defensive layer, I believe, against viruses. Each virus would have to cross a thickness that's 10,000 times bigger than itself, in which it's surrounded by, millions of these soap and water molecules, which would dissolve and destroy it. So that provides an extra safety margin to the common mask. A huge advantage at a very simple cost. So if you're interested in more information, I do want to state that none of the claim benefits here are endorsed by any government agency. But I can confirm that all the ingredients, the methods are proven to do no harm. So at the very least, you have a mask that includes this promising new approach. So it can only be more effective than what you have already. I do have a patent pending on this in a worldwide jurisdiction. But we're happy to share the details at no cost, if it's going to be only for personal use. And also, if it's going to be manufactured and distributed worldwide, which I would very much like to see at a low cost, I'm happy to discuss licensing this technology. Thank you. I hope that helped you learn something about how to protect yourself against this virus, the novel virus. Thank you.